Hello everyone. So this is the final part of the solution of miscellaneous exercise of integrals. So in this we are solving question number 31 to 44. So let us begin. So evaluate the following definite integral. So first one, 0 to pi by 2 sine 2x tan inverse sine x. So let us take this as I. So let I equals to 0 to pi by 2 sine 2x. We'll write it as 2 sine x cos x, then tan inverse of sine x. Now this can be integrated by using the substitution sin x equal to t. Put sin x equal to t. So that implies cos x dx equal to dt. Cos x dx equal to dt. Also we will change the limits. X is equals to 0, that means t will be sine 0 equal to 1. X equals to pi by 2, t equals to 1. So lower limit is 0 and upper limit is 1. So now we'll substitute all of this in I. So limits will change to 0 to 1. 2 sin x is t. Cos x dx will come as dt. So that means tan inverse, again sin x is t, then cos x dx is dt. So 2 can be taken outside. 0 to 1 t tan inverse of t dt. So this can be integrated by parts. Tan inverse t first function, 2 as the second function. So 2 into t as the second function, sorry. So tan inverse of t first function into integral of second, that is t square by 2, and there is a limit, so that is 0 to 1, minus integral, again limit 0 to 1, derivative of first function, that is 1 tan inverse t derivative 1 by 1 plus t square into integral of second, that is t square by 2 dt. So now we'll apply the limits. 2, there is 1 by 2 common in both of them, so that will be taken out. Then first is t square tan inverse of t from 0 to 1 minus 0 to 1 t square by 1 plus t square, that will numerator can be written as t square plus 1 minus 1 divided by t square plus 1 dt. So this will become, if we apply the limits for the first term, it will become 1 into tan inverse of 1 minus 0 into tan inverse of 0. Then integrating this, if we split it, it will become 0 to 1, 1 minus 1 by 1 plus t square. Splitting the terms by taking t square plus 1 by t square, that is 1 dt. So now tan inverse of 1 is pi by 4. So pi by 4, the second term will completely become 0. If you integrate 1, it will become t minus 1 by 1 plus t square is tan inverse of t. Again limit is 0 to 1. So we'll apply the limits for this also. So it is 1 minus tan inverse of 1, then minus 0 minus tan inverse of 0. So that means it will become pi by 4 minus 1 minus of minus 10, that will become plus pi by 4. So pi by 4 plus pi by 4, pi by 2 minus 1. So this is the answer to this particular problem. Now we'll move to the 32nd problem. So again let us take this as I. Let I equals to integral 0 to pi x tan x divided by secant x plus tan x dx. Now here we are using the property integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. So using this property, that is integral 0 to a f of x dx, we can write it as integral 0 to a f of a minus x. So I is equal to 0 to pi. X can be written, x will be f of, here f of x is x tan x divided by secant x plus tan x. So when we take f of pi minus x, because a equals to pi, it will become pi minus x tan of pi minus x divided by secant pi minus x plus tan of pi minus x. Now tan of pi minus x is minus tan x, then secant pi minus x is minus secant x, then minus tan x. Now if you take minus common, this can be written as pi minus x into tan x divided by secant x plus tan x. So that means f of a minus x is pi minus x tan x divided by secant x plus tan x dx. So if you take the given I as 1 and after using this also I, now adding 1 and 2, 1 plus 2 equals, left side will become 2i, then denominator is same, 0 to pi, limits, denominator is same, secant x plus tan x, and we can add the numerator, that is x tan x plus pi minus x tan x dx. So if you add that, it will become 0 to pi tan x divided by secant x plus tan x dx. So this is equals to 2i. So therefore I is equals to pi by 2, 0 to pi tan x divided by secant x plus tan x dx. Now we have to integrate this one. So this can be integrated by pi by 2 is there, 0 to pi tan x, multiply and divide with secant x minus tan x, multiply and divide with secant x minus tan x. This will become secant x plus tan x into secant x minus tan x dx. So now denominator will become, again we'll write this, tan x secant x minus tan x, denominator will become secant square x minus tan square x dx. Now again pi by 2, this can be written as 0 to pi, opening the bracket, tan x secant x minus tan square x divided by secant square x tan x minus tan square x is 1 dx. Now we can integrate 1 by 1, so that is 0 pi by 2, 0 to pi secant x tan x dx minus 0 to pi tan square x we can write it as secant square x minus 1 dx. So that means pi by 2 integral of secant x tan x is secant x from 0 to pi minus secant square x integral is tan x from 0 to pi. Minus of minus 1 is plus 1, so integral will be x from 0 to pi. Now if we apply the limits, pi by 2 secant pi is minus 1 minus secant 0 is 1 minus tan pi is 0, tan 0 is 0 plus x pi minus 0. So that means pi by 2, there is a pi here minus 2. So this is the answer for this particular problem. Now we'll move to the 33rd problem. It is integral of modulus function. So integral of modulus function, it is based on definition of mod x. We have mod x equal to minus x if x is less than 0 and x if x is greater than or equals to 0. So if you use that, mod x minus 1 will be minus of x minus 1 and x is less than 1 and x minus 1 and x is greater than or equal to 1. And same way modulus of x minus 2 will be minus of x minus 2 if x less than 2 and x minus 2 if x is greater than or equal to 2. So modulus of x minus 3 will be minus of x minus 3 x is less than 3 and x minus 3 x is greater than or equal to 3. So accordingly we will split the limits. So let us take this as I. So one by one we can write 0 to 1 modulus of x minus 1 dx plus 0 to excuse me, actually the limit is 1 to 4. So 1 to 4 is the limit. So that means here it will be 1 to 4 modulus of x minus 1, 1 to 4 modulus of x minus 2 dx plus 1 to 4 modulus of x minus 3 dx. Now 1 to 4 means it is starting from 1 only. So that means if you use the definition of modulus, it will become x minus 1. No need of separation here. And 1 to 4 it's modulus of x minus 2. So that limit is to be split from 1 to 2 and 2 to 4, because less than 2 modulus has one value, that is minus of x minus 2, that is same as 2 minus x, and from 2 to 4 it is x minus 2 dx. And same way for 1 to 4 also, 1 to 4 modulus of x minus 3, it is to be split 1 to 3 plus 3 to 4. This is 3 minus x dx plus x minus 3 dx. So now we will integrate one by one and then we will apply the limits. Integral of x is x square by 2 minus 1 is x. So the limit is 1 to 4 plus 2x minus x square by 2, limit is 1 to 2 plus x square by 2 minus 2x, then limit is 2 to 4 plus 3x minus x square by 2, limit is 1 to 3 plus x square by 2 minus 3x, limit is 3 to 4. Now applying the limits, this will become 4 square 16 by 2, 8 minus 4 minus 1 square 1 by 2 minus 1 plus, again applying the upper limit, 4 minus 4 square 2 square 4 by 2, that's 2 minus 2 minus 1 by 2 plus 16 by 2, 8 minus 2 4s are 8 minus 4 2 minus 4 plus 9 minus 9 by 2 minus 3 minus 1 by 2 plus 8 minus 12 minus 9 by 2 minus 9. Now if you simplify this, the final answer will be coming as 19 by 2. So 19 by 2 is the answer for this particular problem. Now we will move to the next one. Next one, prove integral 1 to 3 dx by x square into x plus 1 equals to 2 by 3 plus log 2 by 3. So this is to be done using partial fraction. So let 1 by x square into x plus 1 equal to a by x plus b by x square plus c by x plus 1. So now taking the LCM and simplifying will become a into x plus 1 plus b into x plus 1 plus cx square equal to 1. If you take x is equals to 0, you'll get b equals to 1. X is equals to minus 1, c is equals to 1. Now to get a, we will be comparing coefficients of x square. Comparing coefficients of x square on both sides. Left side the coefficient of x square is a plus c. Right side is 0. So c is equals to 1 implies a equals to minus 1. A equal to minus 1, b equal to 1 and c equals to 1. So therefore integral 1 by x square into x plus 1 dx, which is same as integral minus 1 by x dx plus integral 1 by x square dx plus integral 1 by x plus 1 dx. Now integrating, integral of minus 1 by x is minus log x and 1 by x square is minus 1 by x, then plus log x plus 1. So that means this will become log x plus 1 by x minus 1 by x. So this is the integral for this one. Now we'll apply the limits. Limits are from 1 to 3. So if we take 1 to 3 dx by x square into x plus 1, that means it will become log of x plus 1 by x minus 1 by x from 1 to 3. So now you'll apply the upper limit, log 3 plus 1 4 by 3 minus 1 by 3, then the lower limit log 2 minus 1. So it will become log 4 by 3 minus log 2 plus 1 minus 1 by 3. So that means log a by b, a minus b log a minus log b is log a by b. So this will become 4 by 3 divided by 2, and this is 2 by 3. So that means it will become 2 by 3 plus log 2 by 3. So we'll see that that is only we are asked to prove. So the final answer is 2 by 3 plus log 2 by 3. So we got the required answer. Now we will move to the next problem. Integral 0 to 1 x e power x dx equal to 1. This is to be done. So let us take this as I 0 to 1 x e power x dx. It is to be done by parts. X is taken as the first function, e power x as the second function. So first function to integral of second, then applying the limits minus integral again from 0 to 1, derivative of first into integral of second. So that means this is x e power x from 0 to 1 minus e power x from 0 to 1. Now we'll apply the limits. It is 1 into e minus 0 minus e minus e power 0, that is 1. So that means it will become e minus e plus 1. So the answer will come as 1. So that is only we are asked to prove. So we got the required answer. Now we will move to the 36th one. X to the power 17 cos to the power 4x from minus 1 to 1. So here we are using the result integral minus a to a f of x dx equal to 0 if f of minus x equal to minus f of x. So here f of x is x to the power 17 cos to the power 4x dx. So if you take f of minus x, it will become minus x to the power 17 cos to the power 4 of minus x dx. So that will come as minus x power 17 cos power 4 x. Sorry, there is no dx. Sorry, that is mistake. So minus x to the power 17 cos power 4 x. So which is same as minus of f of x. So that means f of minus x equals to minus f of x. That is f of x is an odd function. F of x is an odd function. So because f of x is an odd function, we can say that therefore using the property integral minus 1 to 1 x to the power 17 cos to the power 4 x dx equal to 0. So we are asked to prove this only. Now we'll move to the next problem. 0 to pi by 2 sine cube x, there is a mistake in this, sorry, sine cube x dx. So we'll take this as I equals to 0 to pi by 2 sine cube x dx. So sine cube x can be written as sine square x into sine x dx. Again, sine square x can be written as 1 minus cos square x into sine x dx. Now if you this will be integrated using substitution. Thus put cos x equals to t. So that means minus sine x dx equal to dt, and we will change the limit also. X is equals to 0, that means cos 0 equals to 1. X is equals to pi by 2, cos pi by 2 is 0. So it will change as I is equals to lower limit is 1, upper limit is 0, 1 minus t square. Then sin x dx will become minus dt. Minus dt. So now integral a to b f of x dx equal to minus of b to a f of x dx. So if you interchange the limits, we can, there will be a negative sign. So that means this is same as integral 0 to 1 1 minus t square dt. So now if you integrate 1 by 1, so it will become t minus t cube by 3 from 0 to 1. So if you apply the limits, 1 minus 1 by 3 minus 0 minus 0. So that means it will come as 2 by 3. So this is the answer, that is only we are asked to prove. So 0 to pi by 2 sine cube x dx is equal to 2 by 3. Now we will move to the next problem. This was 37, now 38. 0 to pi by 4 2 tan cube x dx. So again let us take this as I. So let I is equals to 0 to pi by 4 2 tan cube x dx. So tan cube can be written as 2 will be taken outside, tan square x into tan x dx. So that means 2 into tan square x again can be written as secant square x minus 1 into tan x dx. Now this can be written as 0 to pi by 4 secant square x tan x dx minus 2 into 0 to pi by 4 tan x dx, just by splitting the or opening the bracket and then splitting. Now the first one can be done with substitution. If you take tan x as t, tan x equals to t, then secant square x dx will become dt, and also the limits x is equals to 0 means t equals to 0, x is equals to pi by 4, t equals to 1. So the first one, so if you take, let I1 equals to integral 0 to pi by 4 secant square x tan x dx. So it will become 0 to 1 t dt, because tan x is t and secant square x dx is dt. So secant square x dx will be dt. Now if you integrate this, it will become t square by 2 from 0 to 1. So it will come as 1 by 2. So the first one, it is 1 by 2. So now if you find the integral for the second one, so therefore this is our I. Therefore I is equals to, there is 2 outside and first one we got it as 1 by 2 minus 2 into integral of tan x, that is minus log cos x from 0 to pi by 4. So that means this will simplify as 1 plus 2. Now you'll apply the limits. Log cos pi by 4 is 1 by root 2 minus log cos 0, that is 1, and log 1 is 0. So it is 1 plus 2 log root 2, that is log 1 by root 2, that is minus log root 2. So log root 2 is same as 1 using properties of log, it is minus 1 by 2 log 2. So that means it will come as 1 minus log 2. So this is only we were asked to prove. So integral 0 to pi by 4 2 tan cube x dx equal to 1 minus log 2. So we got the same thing only. Now we'll move to the next one. 0 to 1 sine inverse of x dx equals to pi by 2 minus 1. So let I equals to integral 0 to 1 sine inverse of x, we'll take it as into 1 dx. Now we'll be applying integration by parts, sine inverse of x first function and 1 as second function. So first function into integral of second, that is x, and from 0 to 1 minus integral 0 to 1 derivative of first function, that is 1 by root of 1 minus x square into integral of second, integral of 1 x dx. Now that is, this is x into sine inverse of x from 0 to 1 minus this can be integrated by substitution, x by root of 1 minus x square dx. If I take my 1 minus x square equals to t, so minus 2x dx will be equals to dt. So that means x dx will be minus 1 by 2 dt. So it will come as integral of minus 1 by 2 dt by root t. So that is minus 1 by 2 integral of 1 by root t is 2 root t. So it will come as root t. So that is root of minus root t. So minus of root of 1 minus x square. So that is, this will come as minus of root of 1 minus x square. Then from the limit is 0 to 1. So that is x into sine inverse of x from 0 to 1 plus root of 1 minus x square limit 0 to 1. Now we will apply the limits. 1 into sine inverse of 1, that is pi by 2, minus 0 into sine inverse of 0 is also 0, plus upper limit root of 1 minus 1, that is 0, minus root of 1 minus 0, that is root 1. So it will come as pi by 2 minus 1. So this is only we are asked to prove. This is equal to pi by 2 minus 1. Now we will move to the next problem. Evaluate integral 0 to 1 e to the power of 2 minus 3x. So this can be done directly. This e to the power of 2 minus 3x divided by minus 3 from the limits 0 to 1. So that means minus 1 by 3 is outside. E to the power 2 minus 3 minus e to the power 2. So it will come as minus 1 by 3 e to the power minus 1 then minus e square. So that means it is e square minus e power minus 1 divided by 3. So this will be the answer to this particular problem. Now we will move to the multiple choice questions. The last 4 are multiple choice questions. So dx by e power x plus e power minus x. So here integral dx by e power x plus e power minus x, that is equal to integral of dx e power x, e power minus x can be written as 1 by e power x. So if you take the LCM, it will become dx e power x into e power x, that is e power 2x plus 1, and the denominator e power x will come here. Now if you take e power x equals to t, then e power x dx will be dt. So that means this will come as dt by t square plus 1. So which can be integrated as tan inverse of t plus 1. So that means tan inverse of t is e power x plus c. So tan inverse of e power x plus c. So option A is the correct answer. Now we'll move to the next one. Integral cos 2x divided by sin x plus cos x whole square. Now using the trigonometric identity for cos 2x, this can be written as cos square x minus sin square x divided by sin x plus cos x whole square dx. Now numerator can be factorized as cos x minus sin x into cos x plus sin x divided by sin x plus cos x whole square. Now if we cancel one of the sin x plus cos x, this will get simplified as cos x minus sin x divided by sin x plus cos x dx by cancelling one of cos x plus sin x. Now to integrate this, put sin x plus cos x as t. So that means cos x minus sin x dx will be equal to dt. So the whole thing will become dt by t, which is same as log t plus c, and our t is log of sin x plus cos x plus c. So the answer is log of sin x plus cos x, that is option B. Now we'll move to the next 43rd problem. If f of a plus b minus x equal to f of x, then integral a to b x f of x dx. So integral a to b x f of x dx, let this be taken as I, and here if f of a plus b minus x equal to f of x, using the property integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. So if you use that property, this can be written as I is equal to integral a to b, ax will become a plus b minus x, and it will become f of a plus b minus x dx. Now this will become a to b f of a plus b minus x into f of x, because it's given in the question, that is f of a plus b minus x equal to f of x. So this is also I. Now adding 1 and 2, we'll get 2I is equal to integral a to b x plus a plus b minus x into f of x dx. So that means it is integral a to b a plus b into f of x dx. So therefore I is equals to a plus b divided by 2 integral a to b f of x dx. So this is the answer. I is equals to a plus b by 2 integral a to b f of x dx, which is option D, integral a plus b by 2 integral a to b f of x dx. Now moving to the last problem, the value of tan inverse 2x minus 1 divided by 1 plus x into 1 minus x square. So we are using a trigonometric identity here. This can be written as x plus x minus 1, and this is 1 plus x into 1 minus x. So that is, again numerator can be written as tan inverse of x minus 1 minus x divided by 1 plus x into 1 minus x. Now if you use tan inverse of x minus tan inverse of y, it will come as tan inverse of x minus y divided by 1 plus xy. So if you use this particular formula, it will become tan inverse of x minus tan inverse of 1 minus x. Now if you take the we have to integrate that 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square dx. So that only we have simplified into 0 to 1 tan inverse of x dx minus 0 to 1 tan inverse of 1 minus x dx. Now if you take the second integral and apply the property integral 0 to 1 tan inverse of 1 minus x dx equal to 0 to 1 tan inverse of 1 minus of 1 minus x. That is, using the property, using integral 0 to a f of x dx equal to 0 to a f of a minus x dx. So that means it will come as 0 to 1 tan inverse x dx. So using the property, we are getting 0 to 1 tan inverse 1 minus x dx is same as 0 to 1 tan inverse of x dx. So that means if you substitute here in equation 1, so and if you take this as I will be equal to 0 to 1 tan inverse of x dx minus second one we already proved it to be 0 to 1 tan inverse of x dx. So that means both are same, so that means answer will be 0. So the answer to this problem is 0. So the answer is option B. So this will complete the entire miscellaneous exercise of chapter integrals. Thank you.